Hey, welcome everybody. Today we are going to be talking about domain and how to calculate domain. What is domain? So I'm going to share my screen. I'm going to do a couple quick practice problems. Okay, let's see here. So here we go. Practice problem number 1. Find the domain of this graph. Now, domain, for some of us that remember from algebra, is a set of x values. So what are our x values for this graph? Well, the x values can be any point along the x-axis as you draw up or down. Okay. All of these are our different x values. So if I told you, what x values can this graph be? Well, there's a lot of different answers there. It might be easier with the table. If you had a table, you have your x values, your y values, 1, 2, 3, 4, 9, 12, something like that. The x values, your domain, would just be 1, 2, 3. Okay, that's all that the domain would be. But in this case, with the graph, we could have 1.1 and 2.3 and 4.896. There's an infinite number of points between, what is this, -10 and +6. There are an infinite number of points. There's not just 1 point or 3 points or 4 points. There are an infinite number of points. And we can't write them all out like that. We can't write 1, 1.1, 1.111, 1.2. That would take forever. So there's a faster way to do it, and it's called inequality notation, saying something's greater than or less than. In this case, the smallest x number that we can get down to is -10. The largest number is +6. So we know that all of our x values have to be between -10 and 6. Okay. Well, here's how I would write it quicker instead of writing out all those values. I'd say, since this is a solid point, it can equal -10. So our x values have to be greater than or equal to -10, but they have to be less than or equal to 6. Put an x there, you're done. Another way you might write this could just be -10, 6. Both ways are correct. Okay, sorry, with another bracket on it. Both of those ways are correct. There's not one way that's more right than another. They're just different ways of writing it. Okay. Use brackets when they are solid points, when they can equal it. Otherwise, we would use parentheses. Let's try another problem. Okay. Scroll up, new problem. All right, determine the range of the graph. Well, what is the range? Well, we don't want range problems. I'm sorry, we just want domain problems. Range, 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 range. Oh, come on, give me a domain. Domain. There we go, let's do a domain problem. All right. So here's the domain problem. What is the smallest x values we can get to? What are the largest x values we can get to? What are the smallest x values? Looks like the smallest x values end up right here at -1. The largest x values end up here at +8. So we know that all of our x values need to be between -1 and 8. Okay, so -1 is going to be less than or equal to x. We also know that x is going to be less than 8. Another student, sorry, less than or equal to on -1 though would just be greater than, because it's a hollow point. A student last period pointed out a great thought that, hey, the arrows usually always point the same direction. That's true. Just about always they're going to point the same exact direction. Okay. All right, awesome, awesome. Let me do one more just to make sure that we're all on the same page. No problem. All right, here we go. So we've got everything from -9 to +3. So -9 to +3. Looks like since they're both solid points, the arrows point to the left. Since they're both solid points, they're going to be less than or equal to signs. In this case, it's greater than or equal to. Okay, then x goes in the middle. That's our answer. Now here, I'll type it in just so you can see how it's written. So I've got -9 is less than or equal to x, which is less than or equal to 3. Again, they're both less than or equal to because they both have solid points. Is that the answer that we really want to put on there? Yes. Ta-da! We got it right. Okay, there's another video. Give it a little watch. If you have questions, let me know. We will see you guys.